We'll take a look at some examples regarding differentiation of inverse trigo functions. Okay, so there are three parts A, B, C. Let's take a look one at a time. When I go through this, I also list down the formulae for the three inverse arcsine, arccosine, and arctangent here. Okay, the chain rule version, so that we can keep an eye on it. Of course, I want like to emphasize that the MF27 is without the chain rule version. So if you take a look at the bottom right hand corner, that's for reference. Now, if you see this, arctangent 5x squared. So we will obviously use this one and say, okay, it is 1 divided by 1 plus fx whole thing square, and then you will differentiate 5x squared because you got multiply by f prime x here. That means differentiating 5x squared. I haven't differentiated it, all right? But if you have differentiated it, then you will get the final answer, because differentiating this, actually you will get 10x here. And that's that. That's the final answer. There's no more simplification to be done. So A is quite simple. Let's take a look at B. Now, you have a arc cosine. So clearly we will use this formula. Correct? We'll take a look at this one. Okay, and let's see what we get if we use it. Okay, now this fx in this case is this one. This is your fx, yeah? Sine 2x is your fx. So 1 negative, if you see here, is negative, 1 over square root 1 minus fx, which is sine 2x whole thing square, and then you differentiate sine 2x. So I would prefer that we write this out so that we are very clear what we need to do. So differentiate sine 2x is what? Differentiate sine 2x is 2 cosine 2x. Now the tempting thing to do for many of us is to leave it in this version already. There's nothing else that you can do, all right? Because this is sine square 2x, and you see what you can. There's nothing much you can do. But let us recall. All right, let's recall. There is this identity, sine square A plus cos square A equals to 1, which means that 1 minus sine square A is actually cosine square A. So which means we have this, therefore you have a negative 2 cosine 2x divided by square root of cosine square 2x. At this point you will say, maybe can simplify a little bit. Now the dangerous thing to do is this, all right? Again, I would like to, maybe I use a different ink. Here, let's recall. Square root of k square is actually mod k. Okay, you don't, you may want to recall, you go and look at your tutor, go and find out more why is it like that. I give you an example. Square root of minus 4 square actually is 4. Square root of 4 square is also 4. So no matter what the value is, you will get the magnitude. Alright, square root is always defined as a positive number. Okay, square root is always defined as a positive number. So therefore, we get negative 2 cosine 2x divided by mod cosine 2x. Let's put it like that first. Then you say, oh, okay, maybe that's it. But actually, not quite, because you are given this one. X is between pi over 4 and pi over 2, which means what? Which means 2x is between here pi over 2 and pi. And you take cosine, if you try and cosine, the cosine graph look like this. The cosine graph look like this. This is 2 pi. This is pi. Yes. So for the section between pi over 2 and pi, this part, your cosine 2x is actually negative. Your cosine 2x is actually negative. So when it's negative, then mod, recall, maybe I write here, recall mod fx is actually negative fx if fx is negative. Right, so recall this definition, recall your modulus chapter, you will be able to see that. Therefore, we can get from here to here. Correct? Because mod cosine 2x for the range given here, it is negative cosine 2x. Therefore, your final answer is actually a 2. And I want to recap. The tempting thing for us is to remain here, but you realize that after some simplification, there are a few tricks here and there, you realize the answer is 2. The common mistake is to conclude the answer is negative 2. Don't believe, you try, and you realize that most of the time you will end up with a negative 2. Alright, let's take a look at C. C, we will take a look at this formula over here. Alright, this formula over here, arc cosine fx, which means this. Alright, dy dx, yes, equals to a, you use chain rule, this is to the power of 2, so you bring the 2 down, correct? Most of you will say bring the 2 down. Yes, then differentiating the inside, which is arc sine root x, which is 1, divide by square root 1 minus square root x to the power of 2. Correct? Then don't forget to differentiate your root x here, which is a half x to the power minus half. So there are many layers of chain rule here. Very, very dangerous. It's very tempting to miss out 1 or 2 terms. Okay? Yep. So therefore, you get this. You get your numerator, your 2 and your half goes. Correct? Then you have your numerator as arc sine square root x. Divide by your x to the power of minus half is actually square root x in the denominator. And then you have your square root of, which is this term over here, root x squared is just x, 1 minus x. So if you want to further simplify a little bit, you combine the 2 brackets together. This is almost there already. Your final answer is this. Alright, from here to here is pretty standard. Alright, that's that. Thank you.